frozen this morning. Not bad though. Weather's a complete gem. I'm almost starting to think we might be skipping our rainy season completely here and just go right from summer to winter. Probably not. Now that I've said that, most definitely not. But it's a nice thought to think. I've set this guy aside because he's aesthetically very nice, and I want to use him on the furthest outboard stringer where people are going to see. Now something like this, where each one's going to have to be trimmed and fitted a little differently. I really like to just lay them out, and then I don't end up with two of one and missing one of another, etc., etc. I can write right on it the numbers that we pulled off of the other night. And I know when I'm laying this down, or laying this out. Exactly what is what. Okay, earlier I mentioned stair gauges, and some of you may be familiar with them, in which case just skip right ahead. But if not, this is pretty much how you get your layout, start getting your layout set up. We noticed how essentially every step out of here is basically a right angle as represented by this square. And we know that the run of each step is 10 inches, and we know we have a 6.5 inch rise in each case, and so it's really easy, just transfer that over, stick on our 10 inch mark here, 6.5 here. Obviously there's, you can make mistakes with this, but not if you're paying attention. And there we go, and that's going to be essentially the layout of each step cut out. We have a very healthy throat dimension in here, just out of curiosity's sake. So 5 3/4. So could we have got this out of a 2x10? Yes, just barely. But I'd much rather do 2x12s. In fact, I don't even try to get them out of 2x10s anymore. Let's take a look again at that stair blueprint. Here's part of where the genius lies in having a blueprint like this. Notice the dimensions, 11 15/16, 23 7/8, 35 13/16, etc. It gives the dimension or the layout point of each convergence for the step, and this virtually eliminates any risk of compounding errors. my heavy duty sawhorses are serving another function right now, and I'm really missing them. These little things, you know, they're okay maybe if you want to paint some fascia board or something, but I would not recommend them. They, yeah, save your money. I know I'm using them now just because it's what I got, it's convenient, but you know, in hindsight, I would have just built another 1 or 2 sets of sawhorses than getting these. You'll also notice that I'm not cutting all the way through. And the reason for that is so that I don't have any overcut with the skill saw. Now, if these were interior stairs, and so long as I wasn't looking like I was going to be encroaching on the minimum throat distance, I would overcut these with a skill saw. I'd be fine with that. On an exterior stair stringer, I really don't like to do that. And the reason I don't like to do that is because right in this notch here, when you overcut it, you end up with a spot where water likes to collect. And I'm always concerned that in that saw curve of that overcut, it's not going to be coated with the pressure treat preservative nearly as well. Finn. Guys, I'm sorry about the noise in the background. It's my 3rd day on this project, and every day running is either a leaf blower or a lawnmower. I guess they really like to keep their yard tidy, so I can't fault them for that. It's their right. But I know it probably makes it a pain to hear me in the back with that noise in the background. And it's just something that I just feel, personally, I feel better by just finishing up with a handsaw. It's a quick process still. It's not really any extra skin off my back. But you know, I feel like I've made a better product that way. You know, whether it's the right way or not, I don't know. It's totally your call. At the end of the day, it's just, I'm just sharing some of the ways that I like to do some things. So. I'm just going to show you something that you're bound to run into sooner or later if you're cutting your own stringers, and that is a crack that you didn't see before. You know, this crack really only looked like this before, and when I started cutting it, it started to open up more. And you know, obviously in hindsight now, I can see, you know, I should have noticed that. But I didn't. So anyways, if you find this before you put the pressure treated preservative on, you can still fix it. And what I'm going to do is I'm just going to open the crack up a little bit. I'm going to stuff some PL, some construction adhesive in there, and then I'm going to pre-drill and stick a couple screws in, and that'll hold it fast and it'll be fine. As an extra measure of insurance, what I'll do with this one is I'm going to move this one to one of the inboard stringers. And you know, if this was an interior application, what you would want to do is you'd want to make this one towards on the wall side. You know, quite often your stringers will have a wall on one side, and you know, that would be fine as well. So if you break one clean off, you know, whether or not you can fix it is a bit of a judgment call. I know because of that I am crowding these stringers in so that there's more stringers than minimum code, that you know, I'm confident that this will be fine in the end. So you know, be your own, use your own judgment call, be your own warranty station. But I'll show you this. This will maybe give you an idea in case you run into this, and you know, the rest of the string is still fine. So. some 3.5s. So this one, being our first stringer, is going to be our template. And what I always like to do on the template is I like to start off just leaving the bottom 1/8 of an inch strong. And that just gives me a little bit of extra room just in case I was out with my initial measurements. Now this is when we want to check our template. And first thing we're going to do is we're going to put a ledger line on. Now remember, when you're setting your ledger line here, we're going to be measuring out the same as our risers because we want an even step. But remember, do not, because there's no tread on here, do not measure to the top of your existing platform yet. Measure to where your framing is. Now that is not the case if you're going to have a different tread thickness on here than you will up here. So you do have to remember to keep that in the back of your mind. You're going to have to compensate for that if you're going to have a different tread thickness, because you want to make sure that you have an even step all the way up, right? You know, the first step's a doozy. You can try to avoid that. So checking our steps, and we just have to take maybe 1/8 or 3/16 off the bottom, off the heel there, which we left at 1/8 strong, so that's just fine. We'll knock that off, double check it again, and then if so, we got our template. When we're laying out our stringers like this, we want to just make sure that we remember to place the crowns of each board orienting up. Up, of course, being the area of the board that we are cutting all of our stair notches out of. There's a couple good reasons for this. One is so that we maintain consistency between our stringers. If we did not pay attention to crown and would say we had a deviation of 1/4 inch or 3/8 of an inch between stringers on the crown, and one crown of a stringer was placed down and the next adjacent one was placed up, well, a 3/8 of an inch crown on each of those two boards would actually create a difference of 3/4 of an inch. And that would be a big problem, of course. That would be more than what code would allow for variation between stringers, but that would also be a trip hazard. The other reason we want to keep that in mind with placing our crown up is simply for strength. Now, over time these will settle a little bit, probably not very much because we're building these pretty stout, but just like with floor joists, you want to build it so that as the weight of the structure and as time accrues on these pieces, if anything, they just approach more of a straight stretch, or more of a straight state, as opposed to if we place the crown down, they would start off in a sag state and they would continue to sag as they settled in. Here's something to show. Every once in a while you get one in the pile that just doesn't sort of follow the rest. And you can see our template's flush, but it's a full 1/4 of an inch or so less in width. And it's not a big deal. The thing you got to remember is you want to reference off of the front corners when this happens. Like that. It's okay if the back is out, if the heel, but the toes must always be in, playing with the rest of them. When I was speccing the lumber for this project, I had a decision to make, and it came down to efficiency and acceptable waste. These stringers are 7 feet, 10 and 5/8 of an inch long. So technically I could get these out of 8-foot long boards. But one thing that I've learned is that when you are right on the line, Murphy tends to show up. And sometimes he shows up in a big way. And it's always nice when you're laying out your stringers to be able to have a few inches to be able to move your template up and down so that you don't end up with that large knot or other defect in exactly the wrong place. So in this case, I ordered the stringers at 10 feet long, and although that did mean a total of 2 feet of waste per board, which is no small number, it does add up. It meant that I could be sure that I'd deliver a product that was up to my level of standards, and also that I could possibly avoid some headaches in the process. And that in itself is worth a certain amount. So I got to thinking, seeing how I'm not really in a rush on this job, I would show another way of figuring out elevations on stairs. So last night we used the rotary laser and we got some elevations, and that gave us an idea of how much we had to make an adjustment for on the bottom of each of these stringers. There is 1.5 inches of variance in height of this paving stone walk from between here and there. It's not lineal. The highest point is around here. Looking at this slab that's in place, I suspect that this is just a result of some heavy frosts in the past. So anyways, a rotary laser is great, but I thought I'd show how I used to do it before I had one. And start off with something you can use as a straight edge. First thing you want to do is you want to determine where the lowest point is that a stringer is going to land on. The reason this is important is because that stringer is going to have the least amount of material cut off the bottom. So we did that last night with a laser level. We determined that that was the lowest point, and we adjusted it accordingly so that the bottom of that stringer essentially was at point 0. And now all of the other stringers are going to have more of a cut taken off the bottom. So we use that as our template. So the rest of the stringers right now have more depth on that first step than what they're going to need. We'll have to trim each one down accordingly. You know, in an ideal world, we'd pour a landing slab down here, a cement slab, and it would be even, it would be great. But it's just not always an option. So we started off by finding our level. And our first step is, like I mentioned, we're determining that that is going to be our lowest point. Once we have made our adjustments accordingly, we got our first stringer cut, we're going to set our straight edge on top. It's important to take our block and have it actually sitting where the stringer is going to sit. A little more. Okay, right there. So that's level. We put a line on our block. Now we have our height. Take our speed square. This line represents the height of the foot that'll be down here on the base of the stringer. What we do is we take the existing height, we subtract this height off of it, and that'll give us a difference. whatever that difference is, that's how much we have to cut off the bottom of our stringer, off the heel of our stringer. Once we trim our stringer accordingly, then what we're going to do is we're going to use a string line, and that'll make sure that all of our infill stringers are going to be just right. Right, so this is our other outboard stringer. I've marked the difference in height from what we have to what we need to trim to. Trim this off, and we'll put it in place, and we'll check it. Check our level. It's perfect, right on the bubble. Second measurement we want to check just to make sure that the plane of our treads are still level or close enough. See, we are better than a 1/16 over the run of the tread, so that's good. Place these two, and we can run a string. Just a quick note, at this stage only nail in the 2 outboard stringers. We don't want to nail in the 3 inboard stringers until we finish cutting them down. So we got our hangers placed, and these 3 inboard ones are actually, they've just got one tack in there just to hold them. And so we know that our 2 outboards are good. What we're going to do is just snap a line across the front, and that's going to give us our elevation difference. We can trim accordingly off the bottom. Okay. Yes. There we go. Okay, I just want to get a close-up here. Just showing. So we take our measurement. We have a 1 3/8 of an inch. Disregard this line. That was a mistake on my part. We have a 1 3/8 inch height difference. We have to compensate that much for it. Okay, let's just get a close-up here now of how we compensate for our height difference. So we're down to, we're following the bottom chalk line. And so we got 1 3/8 of an inch. You'll notice that the ground is not level in relation to the heel and the toe of the base of the stringer. So what we're going to do is we're going to come up off of our ground 1 3/8 of an inch, make our mark. We're going to come up back here, also 1 3/8 of an inch, and make our mark. Next we'll join the 2 marks, cut along the line, and double check it. The last step we want to do, check and see if these came out accurate. So we're going to run a string across. we did this right. Underneath each of these, we'll have 1 nail width under the string. Perfect. The reason why we use a nail width, or you can use just about any other type of standard spacer in order to lift the string up off the boards, is if one of these inboard ones were too high, it would be lifting the string and we wouldn't know by how much. And so this way we can check and see, and we know that each one of these are where it should be. But if it were out, we would be able to see it. Like I mentioned earlier, stairs, railings, guards, and codes tend to vary from area to area. So you'll have to do your own research for your specific area. For here, we have a rule that says that all our guards have to be 1.07 meters unless the landing is less than 1800 millimeters or 1.8 meters, which is like 70 and something inches. In real numbers, what that means is our landing is just under 60 inches. So we only need to make a guard rail that is at least 35.5 inches tall. I always go a little bit more than that because you don't have to sweat the details. Let's talk briefly about guards versus railings. When you look in the code book, you're going to notice that railings, what they call railings, are actually handrails. That is the device that you have to be able to grip. There's specific requirements for these handrails, how you cannot have interruptions, how they cannot end short, etc. The guards or guard rails are your actual physical railing. And that's where you have rules such as not having an opening large enough that you can pass a 4-inch sphere anywhere through it, minimum heights, etc. So just knowing the difference in terminology and how it applies to a project like this will help make interpreting the code book a little bit easier. I do it this way because there is the least, in my opinion, the least amount of possibility for errors. Construction of railings is not very forgiving to mistakes or errors. And for that reason, I like to just use more of a mechanical method. This is just one way to do it, but it's how I usually go for. And yeah, it's pretty straightforward, simple, but it works. So I got my straight edge here mocked up. This is going to be the front nosing of our step. And incidentally, just a point to mention, this post has been set so the rear edge of this post is right flush in line. Excuse me, let's go over here, thanks. So the rear edge of this post, or the rear face of this post, is right up in line with the front of the rear tread or the first tread. That's just going to be a little bit of time savings. It means I'm not going to have to cut out around something. So when I measure railing heights, you'll notice they'll say something to the effect of the height is on a tangent based off of the leading edge of the tread nosing, or something similar to that effect. And all that really means is that the height of the guardrail is measured off the leading edge on a tangent, so coming straight vertically up from that point. You'll notice that the measurements would differ. If you were to measure the height of your guardrail back here at the back of the step, it would measure as if the guardrail were taller than it really is. So what they're saying is you have to measure right off the front edge. I like to mark the bottom leading edge mark, and this is essentially that line that gets measured off of. It also establishes an angle. Okay, here we got our two end posts, and these guys are going to be a match set, so that means what we do to one, we can do to the other. Before removing these from the stringers, we drilled our holes so that we don't have to worry so much about our alignment. We can bolt this together when it's done. We also struck a line at the elevation of the step. The importance of striking a line is that it gives us a proper reference point to go to. We don't want to measure off the end of the post, because the end is sitting on the concrete pad and the elevation is uneven on one side compared to the other. So by striking the line, what we're doing is we are putting a reference that is relative to the top step, the tread cut on the stringer. That is going to be our reference as to where the nosing of our stair lies. So for example, if this is our stair tread, it would sit on top of that line, which is relative to, or indicative of the cut line on the stringer, and that would be the elevation. You can see now that we match this up, and these two lines here are in line with each other, and we have probably about 3/4 of an inch difference in elevation off the bottom of these posts. So that's why we want to make sure we don't make the mistake of measuring up off the bottom of the post. You may or may not be very familiar with your speed square. These squares are incredibly useful in many different ways. One of the most common ways you can use this is as a protractor, and it's really handy when you're copying over degrees. So To use this as a protractor, we're going to start by putting, you'll see here that marks pivot. So that's the very inside point, not outer, but the inside point is where we pivot off of. We start by putting it on the acute part of our angle. And what we're doing is just rotating it until we match up with the line that we struck off the bottom of that board. And this is that nosing tangent line that we were talking about earlier. So now we're right on that line. We can measure, and I know it's going to be a little bit difficult to see because I can't get the camera directly in line. But there's 30 degrees, there's 31, 32. We're at about 32 1/2 of a degree. Now this is important because that 32 1/2 degrees is the value we're going to carry over for our cuts up at the top of the post. So I believe I mentioned earlier that we need to have a minimum height on our guardrail of 35 1/2 inches. And so that is, of course, measured off that tangent line of the nosing that we were just talking about. So now, to carry that, I'm sorry guys, I messed up the camera shot here, and you ended up with 30 seconds of looking at the back of my arm. So what I was just trying to show and say here is measure off of the stair nosing tangent line where my left hand is up to 35 1/2 inches and make a mark, and that'll lay out our minimum height for the guardrail. And then use your speed square to draw the line at the 32 1/2 degrees. That'll be where we cut our post off at. Because we're going to cap our post with a 2x6 on the flat on top of our guardrail, so essentially our posts are going to go like that, we can bring down our guardrail by the thickness of this. Let me rephrase that. We can bring the cut down on our post, which will allow for the thickness of this board without increasing the height of our guardrail. We now take our speed square, and we said 32 1/2 degrees, there's 32 1/2. We strike a line. That is our cut line. Then our rail is going to sit on top like that. If we were to make a rough measurement, you can see approximately that off our nosing tangent line, measured on up, we have approximately 37 inches of guardrail height. So that's good. That gives us some extra room to work with, and whenever safety is in mind, it's nice to not be right on the line of the code, and just give yourself a little bit extra room, and you can breathe a little bit easier as you build your project. Well, Finn and I would like to thank you for sticking with us through this longer one. It sure gets dark quick now. It's hard to believe that when I finished the day up, it was only 4 o'clock, and it was pretty well getting too dark to work. So I guess winter really is here. Anyways, take care of yourselves, and next time we'll work on the railing.